be turning off the camera. I guess we'll see in a sec. Yeah, we're gonna turn the camera off. Oh, no, no, no. That didn't work. Yep, and that will be the one removed. That should turn the camera off. Yes, it did. All right. I'm gonna tweak some other settings here while I'm getting prepped. Okay, in theory, I should now see this. And that should turn my mic on and off as needed. Okay, we're scaled down to 2 nodes at the moment, which means we haven't really got enough traffic to scale up yet. Okay, I don't seem to be getting the bandwidth I need to get. At least I'm not anymore. Okay, it seems to be good now. Alright, let's see what else we're looking at here. Why is it? Okay, it's 12K. It's getting throttled. Like it's bursting up to 12K. Alright, let's see if I can fix this. Okay. I think that's resolved the... Well, it's still gonna burst up and come back down, it looks like. But I've only dropped 12 frames. I do. Okay, that should be more readable now. All right, let's see if we're still getting meter work out of it. Yes, we are. Cool. Sorry, I had to unplug the XLR and plug it back in. Probably going to generate some more noise here. Okay. Mike should be in a good spot. And so should Mike. I guess we'll see where this goes.
It's 13 hours.
Okay. I mean, I'm not talking much right now if you're watching this later because there's nobody on the stream. And it's another 10 minutes before the official start, so I'm just a little early. I may have accidentally stopped the recording, kept streaming, but I gotta remember which buttons I'm pushing before I just randomly try to mute the mic. I'm gonna go ahead and start creating a project out of this. So I am not often using this for Go, so please bear with me as I figure out the right tools to use. Doesn't look like there's actual IntelliSense for this. One more try then. Let's see if we got all of them this time. So if it's not clear, I'm installing a bunch of plugins for VS Code to try and get it closer to what I'm used to in GoLand. If I can't get that to work, I might have to open up a session of GoLand, but I can't get it to scale the same way I can with VS Code, so that might be a problem. Okay, so oh, this is the old. Okay, I'm not messing around with that. So let's start with a simple HTTP service. Oh, God. Okay. Yeah, whatever. Why did it? I'm supposed to be able to have more than one. Okay, so probably not the best example. So these are implementing interfaces that are defined in the protobuf generated files here. So if we split that over, So one of the things here is that we're starting both services internally as Go functions. So this, as an example, is a self-contained stack of services. It's got the gRPC host and a JSON REST host built into it. And it's using a library I'll show here in just a minute, but it's using a generator library. So I'm using protobufs, proto-C, to generate a lot of this code, and then I'm just implementing the service. So I don't really have anything I can change for this, but and I'm using the gRPC mux runtime to give me the HTTP mux host. So, and it runs a runtime, generates a runtime. Let's get some more data here. Okay, so yeah, it implements serve HTTP for the dispatcher. Okay, not that useful. At least not as an example. So I think I'm still going to work in this though. We can switch back and forth. So you get an idea. This service is real simple. It just has a bunch of links to some various famous Marks and Matts and Dillons and Moonies and Roonies and Cloonies. I'm sure you can kind of see the weird humor in that. That's how this came about. The Scrum team had been working late hours for 2 days straight, and the next day we finished with the development work around noon, about 10 minutes before it needed to be done. And yeah, it was funny. It's actually been updated a few times. It was originally just an HTML page, and then it was later built into an API service as kind of a thing to do. And then I took the HTML page and hosted it, and then since then it's become a Kubernetes pod. So it's currently hosted that way, including the HTML page. So this is the back end, and then the HTML page is a separate repo that can be updated by others for allowing for theme changes and the like, and other pages. Like, I've been technically live for 8 minutes, and I already don't know what the fuck I'm doing. Oops. I guess we're not kid friendly. Yeah, it's because of this. And we're not going to do this. We're just going to go ahead and empty. All right, I'm just going to go ahead and step through this. We don't need cores. So this is part of my template that I have. Remove that. So the first document we have in here, I need to update this because it's a V1 extension now. But we've got an ingress class here that is set up to talk to the cert manager we've already got installed in the Let's Encrypt prod pod. And the specs for the ingress are it will be hosted at example.out-of.coffee, which means DNS will automatically get triggered. I've got DNS automatically hooked into ingress as well. And then the path is the direct backend root level port 80, which is standard Nginx port 80 default. And then on top of that, we've got a TLS configuration, which will generate a certificate by the name of that in the namespace in Kubernetes. And the certificate will be created for the host example out of coffee. And that's all using Let's Encrypt using a service account. Behind the scenes, it's using DigitalOcean to provision DNS. And the external DNS Helm package is what I'm using to maintain all of that for me. Next up is the service definition. You typically don't need this, even when it's wrong or right. But I have it here as part of my template, and I keep it in there so that we have a scaling layer outside of the Docker layer that we can use as well. For rolling deployments and the like, and also so that we have some extra metrics we can use for maintaining and changing the Kubernetes environment. A lot of that stuff is going to be way out of scope for this discussion because this is just kind of a basics. I mean, I'm not an expert, so this is me from an ops background, learning all this stuff in my own free time, and then later on in work, and then learning more and more and more. But practice makes perfect, right? So the next document is an app document for the apps API. It's a deployment class. The name of it is example out of coffee. The spec includes a selector for example out of coffee to make sure that we have a match label for that. It's currently set up for 1 replica, but I'm going to change this to 3 for demonstration purposes because it should scale up the number of nodes in my configuration as well. All the replicas have a template metadata for labels for app, for example, out of coffee. And the spec is example out of coffee is the name of the container. And I need to... There we go. Oh, I need to... I think I remember the command. Boom. All right. So we've got everything we need here. So, except I'm not running Docker yet. I meant to fire that up before I started. Yeah, remind me there. Okay, started. So I don't have a make file or anything like that. I'm just running the command locally to kind of get it out the door. Build it with the right text. Oh, I'm not in. There we go. All right. So that's the explanation of what that does. And we're done publishing because most of these layers already exist through other apps. So there's not going to be any body. But what I can do is now just deploy it. Yeah, good to know. Toilet paper is arriving today. All right, that means it got created. So I should now see a deployment coming up. And I do. And it's up. And it took 15 seconds. Now, it's not gonna have a certificate yet because that takes up to 15 minutes. And it's also going to take a few minutes for DNS to work. And I probably just ruined my chances of that working. So this is what it looks like on the DigitalOcean side of things. And example has been set up. It's probably new. Great. I think I can fix this. Right. Yeah, I think I may have ruined it for everybody by doing that. Let's see what I can do about that because it's only 5-minute long TTL. Stoneway record. Okay. So DNS is set up, but I have cashed myself out of seeing the thing I wanted to show. Good job. Yeah, it's going to be like 10 minutes before this shows up. Think of another thing I can do. I can. And All right, apply to, and it should be new dash example out of .coffee. And this time, I'll wait for DNS to complete before I do anything. Oh, error on the image pull. Yeah, it needs to be the same. Fixed. This should solve itself. Yep. In fact, the old replicas should be gone. All right. Oops. Yeah, I can't have you seeing that. So I'll refresh this until DNS resolves here. All right. All right. So yeah, certificate's not there yet. Should be using the self-signed Kubernetes. Yep. So as you can see, there's nothing there. If we go back here, modify the example. I'm going to go ahead and deploy both. Trying to remember. Oh. Okay. And then that should pick up the new Docker container in just a second. Looks like it just picked it up. Going healthy. This should be showing the new. Oh, I didn't publish it. God dang it. My fault. I gotta roll out again. Okay. As soon as I see cluster is green. Still no scaling. But okay, this is that finally worked. Exactly the same code. So that is my Kubernetes example. It's for a plain website. If still no response on the host name, have to check it out another time. All right, we still got another half hour left in the stream, so maybe it's time I learned some Rust. So yeah, the certs, since they're stored as secrets, can all be reused. So like if there's a TLS here that's left over from another Helm deployment that I'll be reusing later, but you can tell if a cert is ready if it's got that. Otherwise, it's still got the key that's pending verification through the Acme interface. So let me give you one that's already there. Yeah. I'm not going to show you the key. The cert you can download from the internet. But boom. That's my cluster. It's currently 2 nodes, set to max scale at 4. Yeah, you get to see what my VC range is. Well, to see that I'm running Grafana and a few other tools already. Didn't know you could do this. Would have done this a long time ago. Oops. I guess we're not going to be doing any Rust today. Heh. How about some Go? Look at all that stuff. I might do too much. Well, let's do it this way then. So yes, it's going to take a little bit because there's a lot of stuff running at the moment. Heh. So yeah, this one has a make file. Okay. So yeah, you can ignore that. Those are the old deploy keys for semaphore, which I do not use anymore. Just delete them. Don't need to save delete. Okay, so Hambone is a go. All right, so let's start with the protocol layer. Hambones are pretty simple. It's name and image into position. So the message should just be the name of the person, a string, the image URL, a string, and the position, also a string. The GET request message is fairly straightforward. The GET response message is also pretty straightforward. There's nothing in a GET request other than I'm hitting the API version. So this API actually comes from here. So we can actually update the API version and still return old responses from that version with the same binary. I hope that makes sense. It should. And then we've got the Frowns protocol, which is a little different. The intent here is to have it display a smiley face or a frowny face depending on the level of coffee input through another API. Right now the API defaults to empty. So the end result is if you go to out-of.coffee, you get a frowny face. Pretty straightforward. And yeah, and that's using a Docker container that is not in Kubernetes. That's actually got a small HTML file that does some black magic internally to hide the API. So just about everything we use in here is from the generated library. So we've got the Hambone path. Okay, so oops. Fuck it, make. so make clean, make all. So it's gonna regenerate the proto files in case there's anything changed in the protocols, which nothing has. Oh, and I've also got a helper script here that is not the get ignore. Nope. And basically it just predefines everything I need to download and install protobuf on whatever CI tool I'm using. And then I can, well, I say that, but I don't have this set up for that. So let's fix that. Protobuf. So this will default to 3.51. All right, so we've got, oh yeah, here's some black magic for you. I am using a for each on all the possible gRPC ecosystem Google APIs folders in case there's multiple versions on your environment, and I'm adding all of them to the include path. Protobuf proto-C should default to the highest version semantically in the path, which since the version will be semantically in the path since we're using Go mods, it'll be right here just after this. It'll be another element. It should pick up the latest version in your mods. So if you ever check this code out and try to use it, keep that in mind. This is assuming that you are using a version of all of this and it's not commingled with mods or other packages. Yeah. So the JSON data is defined here, and you probably notice that it lines up with the message. So this is the JSON version of the struct that comes out of this message when it's translated from protobuf protocols. Okay, so I have a service v1 that I put together that basically is just a data store that manages the synchronization between the actual protobuf service and the RESTful service that is externally exposed in the Docker container. The protobuf layer is exposed, but not currently used externally. So it's not used in the Kubernetes config to expose the port externally. So while you'll be able to get to the RESTful API, you will not be able to get to the protobuf API. So first thing I did was a new pattern to generate the object I need. And all it does is read in the JSON data itself. That you pass to it through that reader. So it doesn't necessarily have to be the JSON blob like it's defined. I'll show you in just a second. Takes that reader, reads through it. Though I think instead of this, I should probably be using the decoder pattern in JSON, in the JSON decoder or encode library. I mean, it's not that big of a deal because the data right now is tiny. But if I were, say, streaming a large JSON blob over the network, this could actually have problems if it buffers, because basically it would buffer and then disconnect, because the unmarshal function is just using the buffered read-all reader, and when it hits that, that's what comes out the other end. Well, I say that, and if it is a buffered reader, it should pass through fine, but okay, so if we're using a large one, it has to go all the way through the wire, before it can start translating the object. With the decoder, it can process the stream as it's processing the objects, and it will just, if you know anything about lexical interpreters, it will basically store the tokens until it gets closing for that token, or believes it has closing for that token, and then it will either close it or say, I believe I've got the closing, wait until it's for sure, and then close it out. At least that's how I understand the Go interpreter. Or at least the decoder pattern in Go. So I'm not going to do that today because, bluntly, I'd have to wrap my head around the changes. It would actually reduce this by a couple of lines, I think. In fact, I could potentially turn this into something that takes a function instead and make it just a few lines. I'll have to think about that. All right, so we return the Hambone service server v1, which has the data, a slice of the various entries, and the wait group that is used for synchronization or threading, if you want to put it that way. Not quite the same. We're using concurrency here. So once you have that, you have access to a couple of methods. One being the check API to make sure that so let me show you here. So API version is hard-coded in the binary, so that if someone tries to grab a v2 from a v1 binary, it just won't work. And then for backwards compatibility purposes, we can actually say that, say v3, we deprecate the v1 API, and we then can put in the short bits of logic to short path, say, okay, skip if it's less than 3, or whatever it is that we do. For now, it's v1 is the only version that matters. So this is just surface area later for versioning the API. Get Hambones actually is the handler. Yes, the handler for the version 1 protocol, which is here. So yeah. So we get the context in the request, and then return a response or an error. And in this case, we just first thing we do is we check, hey, does this message have the right API version? As GET requests will always have the API. This is the short path code, meaning execution time is shortened right here, meaning if it fails the API check, we immediately return an error with no response. So obviously we need to do something better than the no response, but this is a very simple API. It doesn't really do anything other than one call, and that is getting the v1 API Hambones endpoint. That's it. That's all it does. It's read only. So what it does then is it will make the response object itself using the Hambone response messages. So what it does, it makes a slice of pointers, which is kind of important for working with protobufs. These objects are almost all structs are always going to be used in a pointer context unless you are literally building the struct data. Like you're doing it at runtime. You're making a Hambone object and then you're passing that pointer to something else as a value. So go through all of the data. We create the protobuf Hambone. We then, exactly as I described, as a non-pointer, and then we assign the pointer value to it. Yeah. Obviously, the data order needs to be preserved, and I think it already does that, but I've left the to-do in there for a reason. I haven't figured out yet why. So then it returns a response, which is an object, or sorry, a struct that is generated by protobuf, the proto-C tool, that has the API version, which in this case is a string that is a v1, and then it has a repeated hambone structure, and in this case it is this translates into Go as a slice. So that's why we have a slice of pointers, and we use the pointers so that the actual value is not lost when we go through some of the export barriers and scope barriers that are a bit out of scope for this. Scope barriers in Go that basically you will lose your values if you're not careful with some of this stuff. And plus, you need a pointer to modify the data with any methods. So if you have any methods that actually target the value and change it, then it needs to be a pointer anyway. So, and a lot of that stuff is exploded from the structures that are the protobufs themselves. So, and if I've lost anybody, too bad. Near as I can tell, I don't have anybody following or watching anyway. So, yeah, it's just me. So, let's still do some efforts here to make this visible. Apparently that's the smallest I can make it. Well. All right, so that's the actual get call when you're doing a get on /v1/hambones. This is what's getting called internally. All right, so when we start the service, we actually start two Go routines. The first one starts, well, first adds one to the sync group to indicate that we're about to start a Go function for that wait group. And then in that wait group, we execute the blocking function start your ERPC. It just keeps running and responding. And then when that exits or errors out, well, actually when that exits, it needs to also mark itself as done so that it doesn't. All right, so yeah, I added that because that's actually an issue there. If this were to crash for some reason, like you got a bad response and for some reason the code and the runtime, I don't know, not likely to happen, but if for some reason in the runtime this Go routine crashed, then or through an error whenever we started it, then before I added this line of code here, it would print the error out and it would just exit the application, which means it would not cleanly exit everything else. But now it's going to return, which means it exits that function and marks that it's finished that function. I don't need the return. Since I took out the error, that's all I need. All right, so yeah, I just shortened the code. And then same thing with that. Wait 2 seconds before starting the rest to make sure that we actually are able to load up the JSON. I mean, 2 seconds is probably way too much time for what data we're loading, but if we had, for example, a giant database that we were loading into memory for some reason, like some kind of, I don't know, like a mud engine or something like that, then we would want it to load first before this happens. We could probably use channels to make this a little more intelligent, to actually, like say add a channel here. So let's do this. startup channel equal new chan struct. I think I did that right? Oh, wait, derp make chan struct. Yeah, that's not gonna work. It's a lot of take a look at this. All right, so let's refactor this. All right, so back channel. Let's see if there's something I'm missing. I thought I knew this. Apparently I don't. All right. That's useless. All right, see, that's what I thought. So this should, okay. And then right. I got that reversed. This one needs to know when that one's done. So All right, now I can do back channel, make chan struct, empty structure. Okay, so what happens now is we start up the gRPC with a back channel, and then we start up REST with a back channel, and then start gRPC. Internally starts a go function that then sleeps before sending back a message saying, "Hey, we've started," because that then gives it a chance to. Wait, I don't need to sleep because I've already got the data there. All right. So, and then we can just do this will block until the gRPC host is up. It should. All right, so that should still work. Okay, so that worked. Thought there was a. You know what? Might as well just use the workflow. Okay, yeah, screw it. Docker build f dot dash f Docker file hambone, and then I made the mistake of stopping Discord. Docker, stopping Docker. So we're actually a little over here, but I don't mind. All right. Let's see if that did it. All right. Docker is building. Ran. Oh, wait. I bet you it's. Oh. That's what I thought. Okay. It started. And it ran. So this code worked. The changes worked. I think I'm good to go here. Let's commit this. Oh, hey, it's actually generating the swagger. It wasn't doing that before. Nice. So let's merge the branch in just in case. All right. Nope. Branch. Uh, all right. Okay, that's new. Yeah, I did a bunch of stuff that I didn't do before. Okay, that's nice. Swagger changes are nice. Go format changes. Don't need to approve it. I just need to make sure checks finish. Boom. Succeeded. Oh. No need to review. I'm the only developer. Pull request. It should now be mergeable without that ugly button. Yep. All right, I'm just going to leave that branch out there. And now that that's happened, I need to merge development to master. I mean, it's going to build the same thing again. I think it will validate the checks, though, and cache it, so it should be pretty quick. Apparently we had 2 viewers at about 1:30. About 2 minutes. This should be done soon. And this should generate a release. Go. So as you can see, it's actually going to go through and build it as a container. So it's actually going to download everything at the versions pinned with my last commit. Sorry, my last commit to the Go modules, which was right before I made the branches that we just used, so it should be good. It's interesting that it deployment seems to have worked. Unchanged, unchanged, unchanged. Okay, so I'm going to need to tell it to do a rollout. kubectl rollout restart deployment. PI out of coffee. So from the perspective of the end user, nothing should have changed. Everything still loads. Meanwhile, in Kubernetes, it's all done. And API out of coffee. "28 seconds ago. New replica set." So basically, I just modified, built, and deployed to my production environment an application in a matter of about 45 minutes. Most of that was me fumbling around figuring what I was going to do with it, what it was going to change. So I think that's pretty good. Since there's no one here, I'm not going to ask for any Q&A. I'm just going to go ahead and end the stream. Have a good one, folks.